So welcome back guys, this is Madhav PVL, and in today's video we are going to see about this V model. So V model is nothing but the extension of a waterfall model. So if you just didn't watch this waterfall model, you can just check the playlist. This video is before video is a waterfall model. So the V model is an extension of a waterfall model. So extension is nothing but waterfall model will have some certain factors, but V model will have something which is different from them. We can just say like a backup. So the testing of a software is planned in a parallel with the corresponding phase of a development. So what is this? So in the waterfall model, if we just see here, the testing will be done only before the deployment. We can just say like this whole thing's testing will be done only before the deployment. You may just ask, what if the testing is not perfect, if it gives a negative result? Then it will just come back to its initial stage and then they will just work from the starting. So for this reason, this is a disadvantage, not good for an object oriented programming, poor model for a large ongoing project. Whereas in the case of a V model, the testing of a software is planned in a parallel along with the corresponding phase of a development. So here we will just write the test cases and we will just compare the test cases before the deployment, whether this application is working in a proper way or not. Writing a test cases is very much important. So testing of a software is planned in parallel with the corresponding phase of a deployment. So here we can just see this is a V model. So requirements gathering, and the next step is the system analysis, and then the software design, and then module design, and then coding. Here we can just see like this is a corresponding thing. So the requirements gathering, acceptance testing, so whether the requirement is accepted or not, whether it is required. So this is a verification phase, whereas this is a validation phase. So verification is nothing but which is done by this front-end developers, and then validation is done with the help of validation is done with the help of a people who type the code, or who we can just say like who were just perfect in the subject. So who knows in depth about the subject will just validate all these things, and then verification is done by the people who were belonging to this management side. So requirements gathered, and then acceptance testing, so whether it is accepted or not, and then system analysis. They will just check for the system analysis, whatever it is, what are the system analysis which is required to just build this application. So system testing is done by them, and then software design, and then integration testing. So integration testing is nothing but is this software design perfect, so it will just check for that integration design. And then module design, so it will just design the module, and then unit testing. So in that particular module, one unit will be tested, so every unit will be tested individually. So finally, if all this 4 plus 4 8 categories are perfect, then it will just get into the coding. So here we can just see like simultaneously both process will be done. So there is a small glitch in this drawing, so I had just made a mistake. So simultaneously they both work, so they both work simultaneously, then the process will be a bit easier for final coding. So this makes both verification and validation go in parallel. This model is also known as a verification and validation model. So both the things are worked parallelly so that the time gets saved, and then we can just say like the validation, so we can just say like the verification will be done initially without the final thing. So this makes both verification and validation go in parallel. This model is also known as a verification and validation model. So advantages are easy to use, and testing activities like planning, test designing happens before the coding. So before the coding, all these 4 are going to happen to just remove the errors or glitches in this particular application. And then proactive defect tracking. So proactive defect tracking is nothing but this, all these 4 are working properly, then we can just avoid the errors, right? Or errors in the sense the defect. And the disadvantages, software is developed during the implementation phase, so no early prototypes of a software are produced. Here we can just say like everything has a particular phase. So prototypes are produced only before the coding, so it doesn't have any particular separate spaces for coding. So it doesn't have any particular time for prototypes, so it will just create a prototype in this particular stage. So prototype is created in this particular stage, so no prototypes are built initially, so it will just get in a proper stages. So if any changes happens in the middle, the whole test cases must be changed. This is a pure disadvantage if we just consider in any process models, but here we can just write it for the purpose of an exam. So here we can just say, like, here if it is causing an error, then the whole thing from this initial stage should be started again. So this is the one of the disadvantage which we can just see in this V model. So I think you might have got some clarity after watching this video. So please subscribe to Works After College, guys. Thank you for watching.